Okay, today we've got this simple problem. We have a continuous function on the segment from 0 to 1 called f. We have this integral where we have x to the power of some arbitrary n, which is the natural number including 0, times f of x. And the integral from 0 to 1 is going to be 0. Have to prove that f of x is equal to 0, and we're given a hint, which is basically the reason why it's such a simple problem and why it's gonna be done really quickly today, yeah? So first of all, any polynomial of degree n capital is gonna be denoted in this way, where Cn is the sequence of coefficients, and this is going to be the polynomial. So let's try integrating the product of f of x with an arbitrary polynomial. What we can do is we can bring f of x inside the sum, then we can bring the sum outside of the integral, and then we can bring c of n outside of the integral too. So what we have is sum from n equals 0 up to n capital of Cn times the integral from 0 to 1 of f of x times x to the power of n dx, which we know is equal to 0. So there's going to be a sum of zeros, which is going to be equal to 0. So we have proven that the product of f of x with any polynomial is going to be 0 if we integrate from 0 to 1. So now we can use Weierstrass theorem to show that f squared of x integrating from 0 to 1 is going to result in 0. So how do we do that? Well, first we're going to write it down as product of f of x with f of x, aka itself. And next what I'm going to do is I'm going to introduce a limit. I'm going to say that I'm going to it's actually going to converge to f of x, but if we were to take an arbitrary point, then it's going to be an approximation. So limit as n approaches infinity of a sequence Pn of x, which is a sequence of polynomials which is going to approach f of x dx. Now, thanks to a bunch of theorems that have been already proven, we can actually bring out the limit. First we're bringing f of x, which is independent of the limit, and then we can bring out a limit outside of the integral. So we have is we're integrate from 0 to 1 f of x times some polynomial Pn of x times dx, and well, we know that it's going to be 0, so we're just taking the limit as n approaches infinity of 0, which is going to be equal to 0. And now, this implies that the integral from 0 to 1 of f squared of x is going to be equal to 0. Alright. Now, this also implies that we were to take f capital of x as the integral from 0 up to x. We have squared, let's call this z dz, or actually let's call it t, it's just more conventional, like that. It's also gonna be 0 because if we were to differentiate this, then we get f squared of t, so it's greater than or equal to 0, so it's constantly rising, and 0, 0 is gonna be, regardless of what we integrate inside, it's gonna be 0, so f of x is gonna be equal to 0, regardless of the x we pick at the bound here. And this has the implication that the derivative of f of x is going to be equal to 0, so f squared of x is going to be equal to 0 on the interval from 0 to 1, so That implies that f of x is also going to be equal to 0. Alright, that's it for today, yeah? Next day's problem is going to be more interesting by a factor. Bye.